In this video, we want to consider some of the basic functions dealing with probabilities from various distributions. Now, the nice thing in R is most of our distribution functions follow the same basic format, and so we consider over here we have the information for a normal distribution. Now, functions that we are most likely to use, at least in our class, are the pnorm and qnorm functions. The dnorm function we don't really make much use of, and the rnorm function is used for generating random values, which we've sometimes used in class, or I use to demonstrate some items, but is not typically used in the things that we are doing, say, for homework or other assignments. So let's consider these two functions, pnorm and qnorm. You can think pnorm is going to find us probabilities from a normal distribution. So P for probabilities. Now, to use pnorm, we need to pass in the value that we're interested in, as well as a mean and standard deviation. So let's use something that we are familiar with. We know by our 68, 95, 99.7 rule that approximately 95% of the data is within 2 standard deviations of the mean in a normal distribution. So let's try the area less than that. By our rule, it should be about 2.5%. It'll be a little less, but it'll be close to that. So in that case, we have a normal distribution. I want 2 standard deviations away from a mean of 0 and a standard deviation of 1. Now you'll notice up here you can see it listed, or over here, that a mean of 0 and a standard deviation of 1 are the default arguments, so you don't actually have to enter those in. So if I run this, I'm going to get the probability, and we do see, yeah, it's a little bit less than 2.5%, but it's very close. In fact, we know as we've continued on learning that the exact value is 1.96. So let's change this out to 1.96, and now we can see our very, very close to 2.5% less than the value. Now, pnorm has some other arguments. Say that we're interested in probabilities from a different random distribution. I want to know what the probability of observing 10 is in a distribution with a mean of 12 and a standard deviation of 4. So the probability of seeing 10, well, remember, we can't see a probability of exactly 10, so what we're going to find is a range. Now, the default is to find the area less than, and that's what this lower dot tail argument does. So if I either keep it the same or add this lower dot tail, I'm going to find the probability of seeing a 10 or less from a normal distribution with these parameters. And so we can see, all right, looks like that is 0.308. Oh, but wait, perhaps I wanted the area greater than. All I need to do is change lower dot tail to false, and then when I run this, I'm going to get the area greater than. And take a note, remember that the area greater than a value is just 1 minus the probability of seeing that less than a value. And so we've simply taken 1 minus 0.3085, so on and so forth, to get our value here. Now that's for pnorm. As a note, this works with a t-distribution, but instead of norm, we're going to use pt. And with the t-distribution, we can pass in a value, say -1, but we also have to specify the degrees of freedom. So perhaps we have a distribution with 10 degrees of freedom. Do note there are 2 arguments in the t-distribution that we do not use in our class, ncp and log.p. Please don't worry about those, but the lower dot tail argument is here as well. So we can find probabilities from a t-distribution. Additionally, we can find probabilities from a chi-square distribution. Now in this case, remember chi-square is always positive, so perhaps I want to from a distribution with 10 degrees of freedom again. Now once again, there's an ncp and a log.p argument. Please don't worry about those. Now this one might seem a little odd. The lower dot tail argument still defaults to true, but for everything that we have done, we've always wanted the area to the right, the area greater. So we're almost always going to want to have lower dot tail equals false when we're working with the probability from a chi-square distribution. Now as a final one, If we want to find the probability from an F distribution, we can again do that, but remember now the extension F distribution is going to be similar to the chi-square, but is going to have two sets of degrees of freedom. So perhaps I had an F value of 7 with 2 numerator degrees of freedom and 100 denominator degrees of freedom, and once again I want lower dot tail to be equal to false. And so we could find our p-value from an ANOVA or an F-test that way. Now all of these are p and then the distribution. So pnorm, pt, p chi-square, and pf. And for all of these, we first pass in the value we're interested in, and then the other bits of information that we may need. Now to take a little break from those and consider confidence intervals. Well, with confidence intervals, we didn't need the probability value. We were given a probability, and we wanted to go back the other way. I wanted to find the value where 2.5% is less than this so that I could have a 95% confidence interval. Now the way we're going to do that is use this other function, qnorm, or for a t-distribution, qt. So if I wanted a 95% confidence interval, I need to find that qnorm value and say I wanted the area where there was 2.5% below, so that there's 2.5% above or 95% between. So this will give me my z star value. And I can specify mean equals 0 and standard deviation equals 1, but we don't have to worry about that too much. And if I run this, I should get approximately negative 0.196. Now if you were to come in here and change this to lower dot tail equals false, I'm going to find the cutoff where 2.5% is above. And by symmetry for the normal distribution, that's just going to be the positive equivalent. Now for a normal distribution, we had most of these and we can memorize the values. So perhaps what's more helpful is the qt function. So if I wanted a 95% confidence interval from a distribution with 12 degrees of freedom, then I can set my t star value equal to 2.179. All right, so these are some of the probability functions that we can use in R to either find probabilities outside of a range. We can use our combinations, add, subtract to find values between two numbers or outside of certain ranges, and then our Q functions in order to find the corresponding star values that we used for confidence intervals.